For disks using the MBR partitioning scheme, the fdisk command line tool is a partition editor that Linux administrators should be familiar with. Let's look at some examples of how fdisk can be used to manage partitions on a disk with the MBR partitioning scheme. We'll begin by creating a new partition on a brand new disk. You must be logged in as a root user to use fdisk. To create a new partition on a disk, execute the fdisk command and pass the disk device name as an argument. On our system, the new disk that we'll create a partition on is /dev/vdb. So we'll enter the command fdisk /dev/vdb. Fdisk will then initiate an interactive session and present us with a command prompt. Enter N to request a new partition. MBR partitioning scheme uses two partition types, primary and extended. Only 4 primary partitions can be created, so in situations where more than 4 partitions are needed on a disk, you will need to create an extended partition, which will then serve as a container within which you can create additional logical partitions. This approach allows you to create a maximum of 15 partitions on an MBR style disk. In this example, we'll proceed with the creation of a primary partition by entering P for primary. fdisk now asks for a partition number for the new partition. This partition number is used to identify the new partition for future partitioning operations. We'll assign our new partition a partition number of 1. Since 1 is the default value, we can simply press the Enter key here. fdisk needs to know where on the disk the new partition should start at. This is specified by the sector number. You will notice that fdisk displays a range of acceptable sector numbers for entry. We will simply press Enter here to accept the default value of the first available sector number. We also need to specify where on the disk the new partition should end at. fdisk accepts multiple input types here. You can specify the absolute sector number that you want the partition to end at by entering a number. For example, we can enter 1050623 to indicate that we want the partition to end on sector number 1050623. Or we can specify sector number relative to the partition's starting sector number by entering a number prefixed with a plus sign followed by the number of sectors that we would want in this partition that we're creating, such as plus 52488. The third and most user-friendly option is to enter the desired size of the new partition. This is specified by a plus sign followed by the desired size. The desired size can be specified in kilobytes, megabytes, or gigabytes. We will use this input method to create a partition that is 512 megabytes in size. fdisk confirms our partition creation request. Notice how the confirmation message indicates that fdisk uses binary rather than decimal data storage units as indicated by MIB rather than MB. So the new partition is 512 megabytes rather than 512 megabytes. All partition types created using fdisk default to partition type Linux. We can see this with the P command, which prints out the partition table currently being edited. Notice that the partition we just created was created with the type Linux. If a different partition type is desired, enter the T command for type and then enter the code for the desired type. To see a list of the partition types and their corresponding partition codes, you can use the capital L command. So for example, if we want to change our partition type for our new partition to be Linux swap, we will enter 82, and then fdisk will change the new partition from the default Linux type to Linux swap. Let's go ahead and add another partition. Once again, we will use N command to request a new partition. We'll enter P to specify that we want to create a primary partition. We'll press enter to accept the default partition number of 2. We'll press enter again to accept the default sector number that the new partition will start on. And then once again, we will specify that we want to create a new partition that is 512 megabyte in size. This time, since we are creating a partition type of Linux, we do not need to do anything else because that is the default type that fdisk will create its partitions as. Entering the P command, we can see that we now have 2 partitions, one of type Linux swap and another of type Linux. At this point, all the partition table changes that we have made are held in memory. To finalize a partition creation, we need to issue the W command to write the changes to the disk partition table. Fdisk will exit after the changes are saved. Lastly, to inform the kernel of the changes to the partition table, we need to execute the part probe command. Entering part probe and passing the disk device name as an argument will force the kernel to reread that disk device's partition table. In our scenario, we'll enter part probe space /dev/bdb. Please note again that all changes made during the interactive fdisk session only reside in memory. Exiting fdisk without writing the change to disk will leave the partition table untouched. This may be the desired course of action in situations where you make a mistake during the interactive session and want to discard all of your changes. Now let's look at how to use the fdisk command to remove partitions on the disk using the MBR partitioning scheme. We'll do so by removing the 2 partitions that we've just created. Once again, we'll execute fdisk and specify the disk device as an argument to the fdisk command. We'll enter the P command to print out the partition table. The output will list the identification number for each partition. Notice how we have 2 partitions. The first one is numbered partition number 1, and the second one is numbered partition number 2. We'll initiate the partition deletion by entering the D command for delete. Since there are multiple partitions on the disk, we need to tell fdisk the number of the partition to be deleted. Since we want to remove the Linux swap partition and its partition number is 1, we will enter the number 1 here. If we enter P to print out the partition table, we can now see that we have only 1 partition remaining. Partition number 1 has been removed and partition number 2 still remains. Let's practice again by removing partition number 2. Once again, we'll enter the D command to initiate a deletion. Notice how this time fdisk proceeded with the deletion of partition number 2 without us having to specify the partition number. This is because there is only 1 partition remaining, and there is no ambiguity about which partition is to be deleted. Once again, all the changes that we have made so far in our interactive session only resides in memory. So we'll want to enter the W command to write the changes to disk. With the changes saved, we now need to run the part probe command on the disk device to force the kernel to reread the partition table and become aware of the changes just made.